Hello everybody, this morning I've talked to you about the module, and two main modules are the modules about the different kind of compilers installed on the clusters. There are mainly two or three compilers installed on clusters, which are the GNU compiler collection. It's an open source software collection. It's a big package including a C compiler, a C++ compiler, Fortran compiler, Fortran 19s, also a GNU Java compiler, and plenty of other stuff, profiler, debugger, and so on. Commercial software done by Intel, Intel company, who provide most of the time also the CPU, the processor, and so the engineer who designed the compilers are in good relationship with the processor, so they can have all the trick and the way to optimize code better or one time earlier than with the GNU compiler. So most of the time, Intel compiler are more efficient in terms of CPU, of take the last point of resource of one processor, one generation of CPU. And the third compiler, which are not so widely used, is the PGI collection. It's now owned by NVIDIA, and it contains a lot of specialties for the use of GPU with Tesla CPU, NVIDIA architecture, and also AMD Opteron code. And there are commercial code, for instance, Gaussian, which must be built with PGI compiler. So PGI is provided on not on all CC cluster, but on, for instance, Hercules or Dragon One. But I see that nowadays, but if user require for it, we can discuss, maybe we can install it also, but it's not installed on Lemaitre 3. But when we will make some exercises after this slide presentation, we will log on Hercules, and you will see, thanks to the CC Home, that the files are directly compiled on one cluster, but can be executed on another one. Depends, of course, on the flags you set for the architecture and the optimization flags. But this is what we can see. So we have seen that this morning two main modules are the GCC and the Intel module, and also PGI. If you log on Hercules, you can, that I've shown you how to check the help, what's the environment, and the fact that module change the variable, the path search for the executable. So when you load the Intel module, automatically the module of the compiler, the executable for the compilation of your code, is added to your path. You see that there is some specific variable which are set by the Intel compiler. There are plenty of other ones, but it's not so important to know that. Of course, you look the path. You can check which Intel Fortran you have. If you don't have any, it will say that I don't have any I4 commandant now. If you purge all your modules, you clean up everything you have in the current bash session, you will not have any I4 back. But if you set it by loading Intel model. The man path is changed. The man path is also available for plenty of other executable, of course, not only Intel compiler at the same time. One instruction very interesting on the Intel ICC is the help. Help provide a lot of things to read, but mainly what I will focus is the optimization flags and the code generation flags. The optimization will make more effort on making a loop efficient. For instance, if there are an attribution of value inside a loop, but which do not depend on the value of the index of the loop, this segment will be put outside this loop, and there are plenty of other tricks of other improvement that can be done by increasing the level of optimization. Of course, if you put a high level of optimization, the compilation take a little bit longer. It's okay if it's a small code, but sometimes it's a very, very big code. And also, and this is more critical, you must ensure that the results are still correct. That means that if you put high optimization, you try to make some approximation for the search of a square or square value of something like this. So they are rounding, and if your problem is a little bit unstable, for instance, multiplication by very, very small value or things like this, the rounding can let you, and at this point you get a completely different result. So most of the time we ask, first, don't make any optimization of your code, and you know that you have this result, and this is the reference result. And then if you try to make harder optimization, check that the result of your code with the same data set is still relevant in comparison with the result without any optimization. The code generation can be set according to the hardware improvement. For instance, the HEVX, which is the way to make small vector extensions. That means that in one loop, it uses different data. The processor sets and put forward in the register different value of data, and for one same instruction, and according to the branch of the result, he use this value or this value, but he can make more instruction in one step with this vector acceleration. And the size, the size of the register, the number of a register is increased according to the generation. So the SSE 4, now we are with 4.3 or 4. If you try to generate a code which take the advantage of all this this improvement on older generation of architecture, this code will fail, saying that sorry, we do not support this instruction, and the code will fail when you run it. So the solution is to make it with the -x generation, but also -a. That means that the code is longer because there is a portion of code for the optimization you asked for, and the other one is for a generic code. And if it failed with at the execution time, when it branched the optimized code, it reached and it branched the generic code, which are slower normally, well, I suppose so, but it will not fail. And so it's a generic machine code. So the compiler do the compilation in more than one step. First step is it analyze the syntax and so on. You must close the bracket. You must respect the syntax, of course. When it's okay, it generates a machine code, an object code, and after that, it takes different library, a mathematical library, because you have called the cosinus and the arctangent and so on. So minus link with mathematical library, link with other library, optimized library, plenty of one, and that can be set by specifying the path where are located this library. And for the generation of the code, you can generate a static or a shared code. A static code includes all the portion of the library inside a big executable, which are independent on the different library. So you get a better portability for this code, and you can run it on cluster or on other working node where the library is not installed because they are included in the binary, in the generated binary. When it's shared, the executable just point to this library, which must be available on the node where the executable starts. The advantage of shared binary is that it's shorter. You see the difference when you make static code and shared code. Shared code contains only the portion, the object code of your sources, and the static contains all the library needed to start your program. I will make after that, yeah, or I can try now to play a little bit with this flop, and I can share this file to you, so you can do that at the same time with me and try different options of compilation. And notice that when you try to improve the flag of optimization, you get better results. Where prompt, I don't know if the size is okay for this. I set it everything into CISM, of course, and I put, for instance, flops.c. So if you want this executable, you can copy this. I'm sure, yeah, it's readable for everyone. You can copy that in your home and work with that. What we can do, we can make plenty of things with this code, but we will compile it for the exercises with GCC. And then with Intel compiler, we will also compile it with PGI compiler on Hercules and try to run it on Lemaitre 3 and see if it's okay or if it's not started. There, first, I must check what are the module, what's the compiler installed for myself at the moment on this bash session. Wrong. Oh. Which ICC, I don't have any C. So model, if I said available Intel, for instance, I said that the first time it takes a little bit longer. Ah, yeah, I have an old, you remember, I have an old tool change. So I will get back to the last tool change module. Load releases, I forget also all the time. Yeah. model available Intel, and you see that there are stuff which are built with Intel, and the main model is this one. So if I don't set anything, I load Intel, model load, ML if you want, model load, and now, which I forged, ICC, have this one. It's a very long path, but it's okay. ICC minus help. Oof, this is long. Less. With that, you can scroll up and down with the arrow. Sorry. The Intel compiler. You can specify, but it's a little bit disappearing nowadays. In 32 bits, there are no more CPU with 32 bits, only in the museum. But this is the optimization. 01, 02 is the default value. So if you don't set any O level of optimization, by default, this is set to 02. 03, more aggressive optimization, and sometimes it doesn't improve performance, so you have to check. So O is the same as O2. O Faust is a bundle, is a package of optimization flags. It's generated O3 and the floating point model, just like what kind of rounding for the mathematical operation, a fast one. So sometimes it's less accurate than the other subroutine for searching the cosinus or the square root of a value and so on. So take care of this. It go faster, but sometimes it go wrong. Generation, this is what I said. If you generate it for SSE4, it will not sometimes work, or the last generation. This one is for Skylake code. So if you run on the AMD Roma processor, it will not run. We can check that after. Of generation of CPU. By default, it generated the code for the machine upon which you compile. So if you compile on a Skylake machine, the code will be optimized for the Skylake. And then if you try to run this code on another machine, sometimes it fails. So there are two options. It's to generate a generic code, or in your submission script, you generate the code and you compile it at the beginning of your Slum script. That's a solution. Plenty of optimization. The tuning. Old generation, of course. You see there are plenty of optimization, and interprocedural optimization, IPO, is something I present next week. Is how to optimize by taking into account the level of optimization inside the subroutine. When you generate your main code, you may include directly the core of the subroutine inside the code instead of branch and use the stack of the processor, which may be a little bit inefficient. But the code is harder and is longer to generate. So plenty of optimization flags interprocedural optimization, link with the matkernel library minus MKL. We're gonna play with that and see the difference when you do your blast subroutine, the call of the blast subroutine yourself, or by using the open source blast compiled by yourself or compiled by Intel, bundled into MKL. ICC minus verbals, I want, flops. Why is that so slow? Usually it's fast. It's a very small program. Demo effects, I'm sorry. A little bit crowd, a little bit loaded. There are people who are working with Python program who are consuming CPU, you see there, but it's not, where am I? This one? No, it was this window. Yeah, oh, that was this. Okay, the verbals, you see all the operation you have done. It's a little bit long to check. You see the version of the Intel compiler and all the definition by default of the definition of value passed to the processor, the preprocessor, and so tuned for Pentium 4 with SSO2. Not so many. And at the end, by default, if I don't have specified an output name for the executable, it generates a a.out program. This is the binary code. If I start it, first I can show you what's this inside. Very small program will make loops, in fact, and a mix of instruction, a floating pointing operation. So floating addition, 14%, subtraction, 23%, multiplication and division. And then combine it and you get information and you calculate how many gigaflop you get on this small code. I execute it. You see the number of floating point operation. I said I don't want any optimization. Minus O0. Oh, if I don't want, I can, it's a warning. Just you see when it's there, it's a warning. Can fix it. It's not pretty, but without warning, it's compiled. I just want the end. You see the difference with this O2, which is the default value, and output flops.o2. Oh, yeah, so, and then out, this is the O0. And then the other one is flops O2. You see the improvements done by this. It's quite important. You remember we are in the CCO subdirectory, and the advantage of this is that it's directly available on other cluster. So if I'm logged there on Hercules and I'm in the same place, I go into CC subdirectory inside this, and they are already there, and I try to run it. What will happen? It work also. Oops. But of course, the value is not so good. And it's not 0. I don't remember. Hey, oh, sorry. $300. Why is that? You can check what kind of processor you get there. It's an AMD EPIC processor. The frequency is not, it's 2 gigahertz. It's an AMD EPIC, and of course, the Intel do not try its best effort on generated optimized code for AMD. That's commercial relationship between the AMD and Intel. Not all the time the best. POD. There. I have the ICC minus X only on. I will set that AVX. This one, I think. Flops AVX 500. Not this. Minus X code generation, and it's not core, must set core, sorry. The warning, I should remove that by default. Final font. Right? Sorry. The search when you tip this one. Common or core minus. Core minus, oh sorry, syntax. Huh? Minus is there. Then it's not very efficient. It's minus O0, O2. You see, bad result. But on Hercules, I try to run it. He refused to run it because he said that processor support Intel, not this one. So this code is not portable on Hercules cluster. That's right. But if you compile it locally, X that means only on. I'll try. Remember, I said the name of Hercules. Oh, if I want, fed with the warning. Yeah. It runs. It's quite good. And then refuse, and give no warning at all. I don't know what's done. That's strange. Usually he said that illegal instruction or it stopped, but there, nothing. Mostly I have to check if it tried to generate a core dump, but I will not investigate now. But this is sometimes user come with a program who crash directly, and we have to search what's the reason of this. We can trace it, so trace the execution step by step, instruction by instruction, and see when it failed. But this is very, very unusual directly. But you see, this is because I've compiled it with -x, and I try to generate an optimized and generic code with 2. Okay. Hey, include x, of course. I'm surprised it should be the same. We will see. There is a delay between the availability of the file on one cluster to the other. There is a small latency, and the system, the shared file system, must bring back the new data to the local cache, and then to offer that to the cluster. Now it works, but this one doesn't. Oh, same. I think that the problem was that it was too fast, and the shared and the common file system was not completely synchronized, and the data was only arriving. I was too fast. There is a small delay of part of a second. That's better. So this one is better. This one with the generic code is not so good. So when you generate a code, the binary and the information of the size can be bigger when you set it in static. I will compile it with -static. -3, I don't want warning, -static. You see the difference, it's huge, it's very big. If I do LDD, that means list dynamic dependency of library dynamic dependency. It's dynamic dependency, of course. Specify the file. It's not a dynamic executable, but the previous one. So in order to run, the program must have a libgcc so library. libc, it's the command C POSIX library, the access of file and so on, the opening of file, closing of file, and the main linking library of the Unix system. And I thought that mathematical library there, LM. And if I make a -static code, all those libraries are included inside. And the advantage is that it's more portable. Normally, it runs also on, say, Hercules. Yeah, the problem of the portability. Even if all the libraries are present, it refuses. That's normal. So, in order to make this, I don't have to set this optimization flags. output is, I would set that static. Because this is going to same there. Where am I? No, this one, it was on Hercules. Not yet arrived. Static is not there. Yeah, just there. So we have to be a little bit patient. And of course, it's not a dynamic executable. You see the difference, and the portability is better with this generation of code. I can go back. So, yeah, I said I can also show you with GCC, the G compiler. I'm on Hercules, but it's okay. Model load GCC. GCC. You see, it's the version 7.3. Okay. GCC minus 0 flops, and I generate it, and the name I choose is GCC 0 explicit. Also, if I don't want the warning, I run it. This one, and then I try to put high optimization level 3. O3 and rep. O3 is not so good. Surprising. O0 is better than O3. That's right. Yeah, it seems the case. We can search what's the reason of this. We can try also another version of GCC. Maybe this version of GCC is not so optimized for this kind of architecture. Remember, it's an AMD EPIC processor, and it's quite a new one, so maybe it's a little bit outdated, the compiler version. Here, if I load the module of GCC, so we use capital GCC, load. Oh, do you understand this? Doesn't complain. Yeah. So it's a new version, but I don't know if it's better. GCC minus O3 directly, O3. Flops.c. I don't want warning, and I generate it as a flops.gcc 8.3.03. Of course, I run it locally. It will be the performance of this processor, which is faster than the EPIC one. Oh no, haven't. Yeah, with O3. And then $5,000 and 9 nearly 2 times faster. Yeah, depends. But you see the difference, and you can check that with Intel and GCC and see which is the most efficient in all the situation with minus O fast also. It's a good point of a very high level of optimization. PGI also exists, and they have its own tags and own settings. Model load PGI. It must match with the GCC version. So it changed the GCC when you load the PGI version. Yeah, it's commercial software linking to an older version of GCC. That's the reason why. PGI CC minus help. And so, of course, the flags are different. That's nice. And also, you see that plenty of option for CUDA generation of code, specifying if you want a Fermi or for CUDA 7, CUDA 8 there. It's also the option to generate a static code. It's minus B static. What's interesting also, of course, not so many used for old generation of code, but it's a little bit depressed. CUDA that I told to you, and this is the target of the tuning target can be from old AMD. You see plenty of AMD version, Bulldozer of Barcelona, to Intel also. In Intel, it goes from old Pentium 4 to Haswell, but nothing for Skylake and last generation. This is why this is what I said about the engineer from Intel. It have the access to the knowledge of the CPU from the inside, and can generate a more efficient machine code with this compiler, because they have all the engineers who talk together and fix every issue they encounter. And you see that there's something which exists to generate generic code for AMD and Intel. PGI tried to make this. Okay, this is also with PGI if you want, but I wanted to show you some memory consideration when you generate a code. Sometimes it consumes a very large amount of memory, and if it's too much, your program will fail. And for this example, I have a small silly program, a Fortran program, and when you compile it, it's just the multiplication of two big array and the sum of and put the result into a third array, and the size of this will be more than 1 gigabyte, or and this or the title is not relevant. It depends. This is the size there, and it's why sometimes too big, because you have a limitation. User have limitation in the amount of memory they can consume on the CPU on the machine at one time. Otherwise, they will be able to overload the amount of memory, even with the cache the swap size. Swap is the extension when there are pages in memory which are not used, they are put on disk on swap. And if you run very big program, it overload the amount of RAM, and they must put the extra consumption of memory inside a disk and swap this when they call and they reach the portion of memory they need. And so the code become very inefficient. The machine spend its time to swap, and your running code is very slow. It doesn't crash because it still have enough memory on disk, but it's slow as hell. So we try to avoid to use swap in HPC, in the HPC world. And also, if it's bigger than the sum of the RAM and the swap, your program crash. Or if sometimes it happens, all the program crash, and you may even crash the operating system. So with a U limit minus O whole, everything, you see different value are important is the stack size. The stack is the portion of code when you have context switching of passing the argument of a subroutine inside code. You put the value of the argument of the subroutine upon the stack. It's used by the subroutine, and then the result is put back on. So the stack is purged by the last value, and the result is put back on the stack. You branch to the main portion, which called the subroutine, and they get back the result on the stack. So if the stack is too small, your program cannot branch to subroutine, and it fails. So in this example, I set a value of virtual memory enough to run, and then I put that smaller than the maximum value of the machine code, and then the program is directly killed. This is sometimes what it happens to your code when you consume too much memory. And so to see, where am I? This one. GCC, no, G420, it's a 4 minus, I don't want any node. Size A dot out. You see, it's very big. And if I try to run it, it will run, okay. Now I run it, A dot out, I put that in background. Is a delay of 1 second, and normally should be seeing my program. Where is that? Oh, it exists. Okay, should be able to see. Control C. I will do that on Lemaitre. So because I have 2 windows. Minus delay 1 second, so it's refresh, and you see the resident size is increasing to reach the value of the virtual size of the program, 42 gigabytes. But it's okay for this because you have enough memory and the restriction, and you see you consume all the CPU. It takes quite a large amount of time. I will cancel it because I don't want to wait. You see, out is there. He killed -9, killed that from hell without any redemption. And on the other one, I have been killed by myself. So this is the consideration of memory consumption. So when you submit a job with Slum, if you must set your memory requirement, and if you overpass and you try to consume more memory than you have asked for, your job is also directly killed. So you must specify and you must check with size, for instance, or you get information at the end of your job, the amount of memory consumed, the CPU time spent, and so on, the efficiency of your program. You must adapt and match closer to the reality. It's your interest, because if you said that I have a small code that use only 1 GB of RAM, but I ask for 42 GB of RAM, I will not start quite fastly. The system will wait for the resource to be available on one node, and sometimes you wait with no reason, because if you have set the real value of the amount of memory you need, you should have started directly. So the advantage of check at the beginning of when you start the serial of code, check the amount of memory you need for this and adapt it to the reality. How to compile ourselves a small code, for instance, a code available on internet, an open source program. I can download it directly. This is a mirror located into Belnet. Belnet is the internet provider of the university in Belgium, for all the Belgian university and more. And this is a very small program. Oh, I don't know what you want. If you get it directly from internet, just like when you are with your browser and you click on something you want to download, and you download locally, and then you put on the cluster. When you are on the cluster, you type wget. As the cluster have access to the internet, it's okay. You will directly your code. I can check if I've done this story. Not on this one. On this one. Well, never mind. I've done this. You can do that if you want. I have this hello. It's a tarball, a compressed tarball. You remember? T to see the contents of it without extracting it. Z because it's compressed. It's a GZ file. Verbose because I want to scroll all the contents on the screen. On the file you specify hello minus. Okay, it will install this on hello subdirectory. It's okay for me, it will be not a mess. I'm there. So instead of T, I put X. And this is mainly what we get when we take a program from the source, an open source program there. We have all the documentation, the configure file, the make file, the new make file, in fact, and README is important. Well, of course, this is more a school case of how to manage a program, because this small program, the only things you do is to write hello world, you see. But it's a GNU project. It's a full real GNU project, and you see how many versions they have done to reach this perfection level. Okay. The best way to do is to check the README. you have the consideration about the license. It's a GNU public license. You can report bugs and see README dev for information on development environment. Install. Install is also something. The basic installation is all the time to make configure dot why a dot slash, because in your path, normally for security reasons, you don't have the current working directory as in your path, because if you are somewhere in a directory which do not belongs to you, and if your path is not well configured and the dot is before, for instance, use bin, if the user have set an ls executable, which in fact do things like this inside the script, no hub. This is very dangerous. I will not tip return. What's that? When you tip ls, it will take this ls and it will remove everything. So don't put the dot into your path. I know it's convenient but it's not recommended for security reasons. I don't know if it will happen. So I configure it. Then I make a make, and then I make install. But there are plenty of options. I just tip configure, and then it check if it have a working compiler and if it works for everything, for second and so on. At the end, it generates the make file, and so after that you can tip make. It will use your make file to generate. You see, you have the logs of your config configure instruction. Check the platform and so on. Plenty of things. The path you have there. Checking for install and so on. If it's okay, if everything works. Sometimes version are not working, and then the make file is this one. Make files contains the place where are all the sources and what to do with the sources, and with different compile option like this. It's very complicated, but I want to check. This is set it by the configure. They find something missing. The GCC, the C compiler I have found is GCC, and the flags they have choose is -G -02. Okay. Then I make file and I compile everything. It's down, everything is down. And if I do make install, it will install, but I don't know where. So I can make -N, I think, by memory. Try to do that, but do not really do it. First check if it's okay. It's the place where you want to put the result. So you make -N install. it do not really do, but it will try to make it by default into user local. And user local, it will fail because it belongs to root and it's not a place where I can, where I have the permission to write. So I can try. I get, of course, the permission denied. How to fix this is to use a prefix option, prefix argument at the configure level. You see, you remember configure help. It's all the time useful. Help is set by default, make install, we try to install in user local bin. But if you decide to set not in user local, but in your prefix, something where you may write, for instance, your home, but it's not so beautiful. One thing I recommended on the previous training session is to create a subdirectory like this. Of course, I've already done this, or you can make this like this. Minus P, if that means if it's not existing, dot local, then I don't know if it's with quote syntax, bin, lib, and etc man. So full structure. Oh, no, it was not the syntax. Sorry, I need to check. I don't do that often. Dire, for instance, bin, lib, etc, man, everything is down into local. Okay, so I configure it with a proper prefix. I said home then. Just like before, check everything if it's okay. And config log is there. I can check it. Path. Where you want to install it. Let's say that. Oh, it's too long. And I'm sure it will be okay. Oh yeah, faster is to check the make file and search for BVR. Autoconf. Next, 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 next. Where is the prefix value? The build here is there. It's okay. The source there, GCC, the target. prefix is there, it's okay. You see. So, quit and make. If I want to go faster, I can make it in parallel for 4 CPU at a time, or 12 if I have, but I'm not sure. Yeah, it's quite fast. Make, I can still make -n to check if it's okay, but I'm pretty sure that it will work. Make install. Everything seems to be okay. Okay, sorry. And which hello? I have hello installed. Hello. Hello world. Hello -help. Next generation, I will try. -n. A great program installed by myself into my home directory on a proper space. With GCC, the exercise is if you want to set a CC value, if you set like this, export CC or ECC and make the configure again, everything will be built with the CC as the Intel C compiler. And normally at the end, it's okay. You can install it. You don't see any difference. Okay. This is how to play with sources, how to install, how to manage the configure, the make file, and the option where to install your software. We are there, of course, to help for real software and real problem, because this is just a small example. Don't hesitate to contact us, and we will try to see if the software is available for you, for your needs. I thank you for your attention. If you have any question, I think that my colleague have worked for that. I will stay in line with the chat to check if there are other questions.
Okay, thank you, Bernard. So we have time for questions, as Bernard said. Do not hesitate to ask them in the Q&A window. The broadcast will be stopped, but we will stay longer to answer questions. Also, please take some time to answer the anonymous survey, and thank you all for your participation.